In this video, we are going to learn about PPK processing and the complete workflow involved in it. We will go step by step and understand how to convert files, perform post-processing, and finally complete the geotagging process. Let's start with the first step. First, we have RINEX conversion. In this step, you will see an option to choose a UBX file. Here we need to select the UBX file, which contains the raw GNSS data collected during the survey. After selecting the UBX file, open the Convert Settings window. This window allows you to configure output format, satellite systems, signals, and correction options before conversion. Select Output folder. In the first section, choose the Output folder, where the converted files will be stored. Click the folder icon and select the desired project directory. This folder will contain the converted RINEX files used for PPK processing. Set logs, duration. Next, configure the log's duration settings. You will see three options: time start, Indian Standard Time; starting time of the log time end, Indian Standard Time; ending time of the log time interval, seconds; data sampling interval. If you want the entire dataset to be processed, leave the default values or adjust based on your required time range. Select RINEX version. In the RINEX version drop-down, choose the desired RINEX. In this example, we select RINEX 3.04, which supports multi-constellation GNSS data and is recommended for most modern processing workflows. Choose data format. In the Format drop-down, select the raw data format used by the receiver. Here the format is UBX. Enable separate navigation file. Next, enable SEPNAV. This option generates a separate navigation file, which helps improve compatibility with different GNSS processing software. Receiver information. Now fill the receiver details. Receiver. Select your GNSS receiver type. Example, SurveyPod. Marker name. Enter the station name or project marker. Antenna name. Enter the antenna model, if required. These details are stored in the RINEX metadata. Approximate position. In the Approx Pose XYZ section, you can enter approximate coordinates of the receiver in XYZ. This information helps initialize the positioning process, but can be left blank if unknown. Pole height and position. Next, configure pole position H/E/N. H. Pole height. E. Easting offset. N. Northing offset. For example, if using a survey pole of 1.8 meters, enter the value in the H field. Correction options. The correction options allow the software to apply GNSS corrections during conversion. Select satellite system. Next, choose which GNSS satellite constellations you want to include. For best results, it is recommended to enable all available satellite systems to increase positioning accuracy. If you want to not include any of the GNSS satellite system, you can uncheck it. GNSS signal selection. Now select the GNSS signals to process. Exclude satellites. In the Exclude Satellites section, you can manually remove satellites from processing. This is useful if certain satellites are known to produce unstable data. Time rounding. Enable time rounding to round off the observation to the nearest integer value. Save settings. Once all settings are configured, click Save to apply the configuration. If needed, click Reset to restore default setting. The software will ask for confirmation, so click on Yes. After clicking Yes, the files will be converted and saved successfully. Once the conversion is completed, click on the OK button. Now we move to the next step, which is post-processing. Click on the Post-Process option. Here you need to insert the rover OBS file. This file contains the observation data from the rover receiver. Next, you need to insert the base OBS file, which contains the observation data from the base station. After that, you need to insert the rover navigation file. Open the Convert Setting window 1. Output folder. This is the location where the PPK processed results will be saved. Click the folder icon. Select the project directory. The processed coordinates and solution files will be stored here. Logs duration. This defines the time range of GNSS data to process. Time start, Indian Standard Time. Start time of GNSS observation. Time end, Indian Standard Time, end time of GNSS observation time, interval, seconds. Data interval for processing. Usually this is automatically detected from the log file. 3. Position mode. This determines how the rover was moving during data collection. Example, kinematic, for drone surveys, mobile mapping, or moving receivers. Static, for fixed survey points. Single, for standalone surveys, where base corrections are not required. In settings, it is kinematic. 4. Frequencies. This defines which GNSS signal frequencies will be used. Example, L1 plus L2. 5. Solution settings filter. Type combine. Merges forward and backward solutions to produce a more accurate and stable result. Elevation type defines the reference model for satellite elevation. You can select ellipsoidal, elevation mass. Minimum satellite elevation angle. Example, 0 degrees means all satellites are used. Usually 10 to 15 degrees is used to avoid low satellites. 6. Integer ambiguity, IA, resolution. This controls how the software resolves carrier phase ambiguities. GPS fix and hold. Once ambiguity is fixed, it remains fixed for stability. GLONASS fix and hold. Same concept applied for GLONASS satellites. BeiDou on. Enables BeiDou ambiguity resolution. This improves centimeter-level positioning accuracy. Base settings 7. Base position defines the base station coordinates. Options. RINEX header. Coordinates taken from RINEX file metadata. Base JSON. Coordinates loaded from a JSON configuration file. 8. Base coordinates. If entering manually, latitude, decimal, longitude, decimal, height, ellipsoidal. These define the exact base station location. 9. Base receiver settings receiver. GNSS receiver model used for the base station pole length. Height of survey pole. Antenna height, distance from pole top to antenna phase, center. Correct values are important for accurate results. Rover settings. 10. Rover receiver defines the receiver used on the rover unit. Pole length height of the rover survey pole. Antenna height distance from pole top to antenna phase center, satellite system. This section selects which GNSS constellations will be used. Using multiple constellations improves satellite availability and accuracy. Save settings. After configuring everything, click Save to apply the processing settings. Click Reset to restore default values. Once all these required files are inserted correctly, click on the Process button. The software will begin calculating the data. If all the files are inserted correctly, the processing will complete successfully. After the processing is completed, you will see the computed results. Now we move to the final step, which is geotagging. Click on the geotag option. In the POS file section, you need to insert the POS file of the rover. Next, in the POS event file section, insert the event POS file of the rover. After that, in the rover log section, insert the rover log file. Once these files are inserted, you also need to select the image folder that contains the drone images. After selecting the image folder, choose the first and last image of the folder so that the software can synchronize the timing correctly. After uploading all the required files and selecting the images, click on the Geotag button. The software will start the geotagging process, and the coordinates will be assigned to the images automatically. Once the geotagging process is completed, your images will be ready for further processing in the mapping workflow. You can see that the geographic coordinates obtained through PPK processing has been embedded into the image. This confirms that the images have been tagged successfully. Thank you for watching this tutorial, and I hope this video helped you understand the complete process of PPK processing and geotagging.